Salam sejahtera Dr. Junaida. We are group 1 from section 4. Now we are going to present our group project.
Now I will talk about the introduction. The interpolation is a computational and mathematical methods that is straightforward and easily to apply to determine the missing data. The Lagrange interpolation is a process of approximating a function f(x) and predict the missing function value over the interval ab. There are various degrees of Lagrange polynomial interpolation in Lagrange interpolation, which are first degree, second degree, third degree, fourth degree, and so on. The different degree Lalang interpolation polynomial have different formula. It is comparable straightforward than Newton divided difference method due to it did not undergo calculation of difference and it is more flexible and no approximation error.
Our problem statement is, as a hydrology and civil engineer, accurately estimating water levels in rivers, lakes, and reservoirs is essential for effective stormwater management, flood mitigation, and drainage system design. Water levels are typically monitored as discrete time intervals, such as hourly or daily measurements. However, for more precise analysis and designs of flood control systems, it is necessary to estimate the water levels at intermediate times. Given discrete water level data at hourly intervals, this project demonstrates how Lagrange interpolations can be used to estimate the water level at 3.5 hours for design purpose, helping to provide more precise input for hydraulic models and infrastructure planning. There are three objectives in our project. The first is to understand how to interpolate the data using Lagrange interpolation. Second is to understand how to apply Lagrange interpolation in real-life situation. And the last one is to solve problem by using numerical methods.
My name is Kahusa binti Adnan, manometri ECF210314. I will present about literature review, language interpolation, find practical application in various fields due to its ability to estimate unknown value between described data point in engineering and physics. Is it will used to estimate physics and quantities such as pressure, temperature, or speed, especially when measurements are taken a discrete interval.
For methodology, the first step we are collecting the data of water level at Sungai Pungai Kota Tinggi from the website The Public Info Banjo. And the second step, we tabulate all the data into a table form to form I, Xi, and Fxi. And third, a haptic approximation is formed, which n plus 1 equal to 8. And the fourth step, the first degree, second degree, third degree, fourth degree, fifth, sixth, and seventh degree Lagrange interpolation polynomial are calculated, and the formula is listed below. And fifth step, the P7x is calculated. And the last step, we substitute the value of x into the function, which the x we need to find is 3.5.
For the calculation part, because we have collected 8 hours of water level data of Sungai Pungai River, which n plus 1 equals to 8 and our n is 7. So, by using the Lagrange interpolation, to find the 3.5-hour water level data, the formula is shown as below. We add all of the Lagrange interpolation polynomial together. The first degree Lagrange interpolation polynomial is found by using its formula. After that, the second, third degree Lagrange interpolation polynomial is also found as shown in the next slide. We will find it until the seventh degree as our n is 7. After calculating the first degree, second degree, and third degree until the seventh degree Lagrange interpolation polynomial, the P7x is formed. Finally, we substitute x equals to 3.5 into the equation and we found that the water level data in at 3.5 hours is 0.9957. In the part of discussion, Lagrange interpolation was applied in calculation to determine the water level and time interval between the data points. Based on the calculation, the water level at the time interval 3.5 hours is calculated as 0.9957 meter depth, considered low in Sungai Bungai Kota Tinggi, Johor, Malaysia. According to the calculated data, we can obtain that the estimation water level at the time interval is 2.5 hours, and we can predict that the flood will not occur at that time. Therefore, stormwater can effectively managed by using the Lagrange interpolation to estimate the water level at the specific time intervals. Besides, an efficient drainage system can specifically for this area is designed by knowing the data of water level when rainfall. Other than that, by using the Lagrange interpolation to predict whether the area will be flooding or not. In this case, people can be evacuated early and prevent accidents occur to ensure their safety. However, Lagrange interpolation may not always be the best method depending on the context and the requirements for the estimation. For instance, Lagrange interpolation can be applied when data points such as time and water level is known. Predict water levels for specific time or distances when data is missing. In this case, a better alternative method to estimate the water level is by interpolation. In this method, it applies a piecewise polynomial to avoid oscillation and ensure the smoothness. It also suitable for the water level data that requires a smooth curve.
In conclusion, language interpolation is a powerful and versatile numerical method that provides an effective solution for interpolating data when the exact functional form is unknown. Its simplicity and flexibility make it particularly useful in fields such as engineering, computer graphics, economy, environment science, and geographical information systems.
That's all from us. Thank you.